Problem 7. Hierarchical softmax with Huntsman tree from the course learning vectorial representation of the words. The main objective of this problem is to implement an hierarchical softmax using a binary tree. The hierarchical softmax is an efficient alternative to the traditional softmax because it does not need a calculate probability for every word in the vocabulary. In this method, the vocabulary words are presented as the leaf node of the binary tree. The internal nodes of the tree contain a parameter vectors. To predict a particular word, the model follows a path from the root of the tree to the word's leaf node. For each step along the path, the model calculates a probability using a signode function. The probability of the target word is obtained by multiplying the probability of all decisions along the path from the root of the target word. The mathematical objective is to minimize the probability of the correct word. In practice, we minimizes the negative log likelihood loss. The loss is calculated by taking the negative sum of the algorithm to signode probabilities along the path. One important advantage of hierarchical softmax is the computation depends upon the length of the tree path rather than the entire vocabulary size. Since the tree is binary, the number of decisions required to reach a wood is small. That calculate a full softmax over the vocabulary word. The implementation was developed by the scratching using the text corpus. The method uses a vocabulary size of the 10,000 words and then embedded dimensions of 100. During the training, the model follows the tree path of for each target word and updates the internal load vectors and contain vectors using gradient descent. The project also generates a training loss curve to show how the loss changes during training. The result of 100 dimensional hierarchical softmax word embedding are saved for the further use and evaluation. The successful gradient checks confirms that the mathematical implementation is correct and the probability normalizing check confirms the probability across the complete vocabulary sum of 1. Therefore, hierarchical softmax is an important technique for efficient training word embedded models, especially when working with the larger vocabulary.